Hello there. During this session I'm going to be talking about the concepts and some of the postulates of special relativity. So the first thing I'm asked to do by the IB is describe what is meant by an inertial frame of reference. So that seems a sensible place to begin. Now, an inertial frame of reference can be defined as a coordinate system which is not accelerating, and a reference system in which the Newtonian law of motion is valid, specifically one in which for a mass m subjugated with a force F moves in accordance to the equation F equals ma, where a is the acceleration. So a non-accelerating system. That is an inertial frame of reference. And these we're quite happy with. And these work in a situation where we've seen in my last session that Galilean transformations allow us to work out locations from one system to another system. Now let's think about this in a little bit more extended fashion. Maxwell, James Clerk Maxwell, came up with a unifying theory of electricity and magnetism. And he produced an equation, a now famous equation, which showed that there's a relationship between the electric field and the magnetic field, and also the velocity of light. Now this equation is really, really important because it's been humorously considered like this. And God said, and then there was light. It is the formula which shows the derivation of the existence of light to some extent. You don't need to know the finer details of this, which I think is good news, but the key thing which came out of here is that Maxwell's speed of light was interesting because it came from epsilon 0 and mu 0. These were two constants from electromagnetism. Now that seems strange because if they're two constants, that means that the speed of light must be a constant. And if the speed of light is a constant, that doesn't quite fit in with our thinking about frames of reference, and that speeds and velocities are always relative. So this is obviously creates a quandary. Now this is a quandary which Mr. Albert Einstein and earlier Lorentz and Maxwell recognized, that it seems that all observers would see light travel at 3 × 10⁸ meters per second. So this is, like I said, as something which contradicts common sense. It contradicts the Galilean transformations we had beforehand, and it's something which really made scientists have to reconsider and reevaluate their thinking. Einstein was there having thought experiments, thinking, what would happen if I was travelled riding a beam of light? Would I still see the light? So the question is it relative? Clearly not. This is absolute. It doesn't matter where you're observing it. Now this puts down or creates an interesting situation. Einstein created two postulates, okay, of special theory of relativity, and you need to know these, okay? These are things which are often asked for specifically in IB examination. Postulate number 1, all laws of nature are the same in all uniformly moving frames of reference. Okay. Any number of experiments can be devised to detect accelerated motion, but none can be devised, according to Einstein, to detect a state of uniform motion. So these uniformly moving frames of reference, so we have an inertial frame of reference, we can't work out if we're stationary or if we are moving at a constant motion or not. So therefore absolute motion has no meaning. Okay, it's all down to relativity. So because of that, in no experiment, mechanical, electrical, or optical, has ever been able to reveal absolute motion. There's no absolute point which we can work from. That's his first postulate. Okay. And it's kind of an extension of the thinking we had beforehand about how motion is relative. And this is known as the first postulate of relativity. Now his second postulate in the special theory of relativity was this: the speed of light in free space has the same measured value for all observers, regardless of the motion of the source or the motion of the observer. That is, the speed of light is constant. So we're saying that here the speed of light is an absolute value independent of the observer's motion. So with this thinking, it means that in the past we would have said if there was an astronaut shining a spotlight which was travelling at 3 times 10 to the 8 meters per second, and an astronaut flying a spaceship at 1 times 10 to the 8 meters per second towards them, then as seen by the astronaut, the light would be approaching her at 4 times 10 to the 8 meters per second. This is now shown to be incorrect. So, as seen by the astronaut in the spaceship, the light would still be approaching her at 3 times 10 to the 8 meters per second. This is an absolute. So this really is the key point of Newton's second postulate. No matter where you're observing it, light will always travel at 3 times 10 to the 8 meters per second. This puts forward an interesting consequence. Okay, so the second postulate occurs the concept of simultaneity. Do things happen at the same time? Two events are simultaneous if they occur at the same time. That kind of makes sense. But there's a problem here. We're going to consider now a light source in the exact center of a compartment of a rocket ship. If we turn the light on, my observer would see that as he's in the exact middle of the rocket ship, that light reaches either end at exactly the same amount of time. It'll be simultaneous. And we're kind of happy with that. That seems to make sense. However, an observer watching the rocket fly by and seeing the light turn on will see that there's a much shorter distance traveled from the light to the back of the rocket compared to the front of the rocket. So therefore she would not observe this occurring simultaneously. So that means what is simultaneous for some observers is not simultaneous for other observers if they're in a different inertial frame of reference. Okay. So that's kind of the idea that simultaneity gets thrown on its head when we really take this to the extremes and really introduce the ideas of special relativity. Here's a question, an IB question. Okay, it's based on this thought experiment. In the diagram below, Miguel is in a railway carriage that is travelling in a straight line with a uniform speed relative to Carmen, who is standing on the platform. Miguel is midway between two people sitting at opposite ends of the carriage A and B. At the moment, Miguel and Carmen are directly opposite to each other. Person A at end A of the carriage strikes a match, as does person at end B. According to Miguel, these two events took place simultaneously. Discuss whether the two events will appear to be simultaneous to Carmen. Now, think about what I've just said. This is a question which basically asks you to explain that situation. But remember, there's 4 marks available here. So take a moment, try and answer the question. And now let me show the answers here. They need to make a statement clearly saying that they will not appear to be simultaneous to Carmen. Any discussion along the lines of Carmen sees Miguel move away from signal A, and since Miguel receives the 2 signals at the same time, and since the speed of light is independent of motion of the source, Carmen will see light from A first, and light from B will reach Carmen after light from A. So anything to those effects, words to those effects are what we're looking for. Okay, but the key points are what Carmen will see, Miguel receiving these things at the same time, and the speed of light being independent of the motion of the source. It will be the same for both observers. So, to finally recap, if I have a spaceship that is leaving a space station, we're going to observe certain things. A flash of light travelling at 300,000 kilometers per second, or c, is going to be emitted from the station. An observer in the rocket sees the flash of light pass her at the speed of c. If the flash is sent to the station from a moving rocket, the observer on the station will measure the speed of flash to also be c. All observers who measure the speed of light will find it has the same value, c. And with this we enter the crazy world of special relativity, and more on that in future sessions.